Okay, welcome. Today we're going to be doing the acid-base chemistry lab. And because schools are closed, we've got my assistant Lily Rowley with me today.
And monkey and koala.
There's not a whole lot to go over, so we're going to be just talking about the fundamental reaction of acid-base chemistry, which is water autoprotolysis. You can write this in two different ways. H2O liquid, form H plus aqueous plus OH minus aqueous. And that's a quicker and easier way to talk about acid-base chemistry, the H plus concentration for acids, OH minus concentration for bases. But there's also a more physically accurate and relevant way to write this, and that is by using the hydronium ion in place of the H plus ion. So please try to not be too distracting to the students. Thank you. So H plus doesn't really exist freely in solution. It will always attach itself to either one water or a group of waters, and we can sort of represent that with the hydronium ion. So for that we would have 2 H2O liquid into H3O plus aqueous plus OH minus aqueous. So that's happening in water all the time. There's nothing we can do to prevent it or stop it, and it is really central to how acids and bases will react with water and how they'll interact with each other. So I want to show two more types of reactions. Okay, we could have an acid in water, something like HCl. We could have HCl aqueous plus H2O liquid. HCl is a strong acid, and it's going to produce that H3O plus aqueous hydronium ion plus Cl minus aqueous. So that is an acid with water. You'll notice it's left behind that chemically inert chloride ion. And then something like sodium hydroxide, NaOH, aqueous. It doesn't need to react directly with the water. It will just dissociate into the OH minus aqueous plus Na plus aqueous. So sodium hydroxide will produce the hydroxide ion, and again a chemically inert ion. And you'll notice that Na and Cl are the components to sodium chloride, regular old table salt. And we're going to be investigating the reaction between hydrochloric acid and sodium hydroxide in a little bit later. Now the last type of reaction that I want to talk about is the solvation of a soluble salt. If I take something like sodium carbonate, for example, and dissolve it into water, then it's going to form sodium ions and carbonate ions. Sodium ions are chemically inert, but carbonate is a base, and so a solution of sodium carbonate will be basic. And with that, let's move to the reactions. Okay, I thought it'd be fun if we have Lily here.
Hi.
Do the lab procedure according to my instructions. And the first thing she needs to do is put on some safety goggles. Let's get your hair out of the way.
Monkey.
Oh, monkey caught on by his tail. Look at that.
Oh. You were lucky, monkey.
Okay,
I look like a scuba diver.
a little bit. Now, we have some reagents here. We have sodium hydroxide,
Okay.
and we have hydrochloric acid. So you've got 2 test tubes, Lily. Can you use these droppers to follow the instructions? Put 2 dropperfuls of sodium hydroxide into this test tube right here.
This one?
Yep. Into this test tube right here.
Is this a dropper full?
Yep. And one more.
And this is an acid, right? Ish?
Well, we're going to find out actually.
Okay, I know that some of these stuff is going to be acid because I heard Dad talking about it, so I'm just going to be careful around my hand.
Okay. Now it says to use a glass stir rod,
Because apparently...
dip it in the solution, and then touch it to the red and the blue litmus paper. They can't see the red and the blue litmus paper unless I lift it up
Do
here.
I just, like...
Just tap it to one end. Like that, and then on this one as well. Okay, we'll set that aside and bring the camera over.
The red one turned blue on the tip.
Okay, so as we see, the red litmus paper turned blue. The blue litmus paper remained blue.
And it just got darker because when paper gets wet, it turns darker.
That's correct.
That's just what happens. I don't know why.
Now, we're going to do the similar thing with hydrochloric acid. So, use this dropper
Okay.
to fill this test tube with hydrochloric acid. 2 dropperfuls.
2 droppers. I think I might have just almost acided my dad.
If you do that, then I'll just wash
it.
my hand. That's right.
Do you get an itchy rash if you don't wash it soon enough?
With 1 molar hydrochloric, you probably would. Okay, could you use the stir rod? Dip it in here again.
This one?
Yep.
But doesn't it have the other thing on it?
That's okay, just a little tiny bit. And now touch it against the other ends of the paper.
Hey!
It's stuck, doesn't it? Okay, we'll show you the results.
It did the other thing. It did it the other way around.
It did, didn't it? Okay, oh, so the blue filter paper here, she touched on this end and it turned red. The red filter paper
Wait, if we use green and
red.
blue, would it do the same thing? Because I love green and blue and they go really good together.
There is no green pH paper. I've been calling it filter paper. It's not filter paper. It is pH indicator paper or litmus paper.
What is this? Like
Okay.
how bright a light is?
What's that?
Is litmus paper like how bright the light?
Not lightness, litmus.
Oh!
Now can you pour both of the contents into this bigger test tube? Try to do it carefully.
Because I don't want an itchy rash.
That's right. There you go. And then we'll dump it. Very good.
Hey, there's some stuff in there.
Now the other one. Dump it.
I think there might be a little tiny bit more of this one than that.
That'll be all right. Okay, and we want to mix this really well, so can you just blow bubbles like that?
Okay.
That's probably good enough. Okay, so we have
The mix.
we've got the mix. Now it says to pour the contents of the test tube into the other test tube and mix the contents well. And then pour the resulting solution into a clean evaporating dish and evaporate it to dryness over a boiling water bath. So we've got this evaporating dish already set up over boiling water. And I just need to pour it in here.
Is it gonna be make red smoke or something?
No, it's far less dramatic than that.
Man,
All right, now
it's so cool if it made red smoke or something.
This is going to take some time, but because we have the boiling water already heated up, it won't be that long. What we'll do is just leave this here and use some time acceleration in the editing to make it fast for you. And we'll see what's in the evaporating dish after all of the water solvent has boiled away.
Okay.
Okay, I think we're pretty much done here. You may be wondering why we don't just put the evaporating dish directly over the flame or something like that. And it's we evaporate it this way for the same reason that you might melt chocolate in a double boiler. We want the evaporation to be slow and gentle. If we put the evaporating dish directly over the flame, it would all evaporate so quickly that it would sputter and we'd lose a lot of the salt. So I'm not sure exactly how much you can see. Let me try and give you a very direct view of what's inside that evaporating dish.
It smells.
Yeah, that's the gas.
Ooh, I love gas. Does it turn us into zombies or anything?
No.
Oh man. That would make it, like a TV show.
So we're going to pull this off.
Like, can it turn us invisible?
Set that there.
Turn us into
Pull this off and set it down as well.
Make magic stuff appear. It has to at least, like, make it possible to pull a bunny from a hat, right? Actually pull the bunny from the hat. No secret compartments with flaps in the top of it.
Okay, we're going to leave that burner going for a moment because there's a part that's going to need the burner. But and now it says that we're supposed to divide this solid. First of all, let's have Lily describe it since she can see what you can't. What does it look like in there?
Can I take off my goggles? I think they're
Yeah, you can lift them up.
It looks kind of powdery.
What color is it?
It's white. And it's not like that yellowy white that the crayons have. It's like the snow.
Okay, get your goggles back
But
on.
it's not Snow White the Princess from Disney.
And can you put 20 drops? We've got deionized water here. I'm actually going to tilt everything down a bit now. That's probably better. We've got deionized water here and an empty test tube here. Lily, can you put 20 drops of water into that test tube? Put the dropper back in the deionized water. And it says to divide the solid into 2 parts. So we scrape it up like this, and perhaps is what I should have done originally. It may not have looked like much, but there actually is a fair amount of solid here. So can you put about half of that into this test tube right here?
Okay, so like, is that about half of it or like 1%?
At least 1%. Now you can use that to stir it a little bit.
Oh. How did the liquid stuff turn into solid?
What?
It was
Oh, that?
liquid or liquid.
Yeah, good question. When all of the water evaporated away, then stuff that was dissolved inside of it got left behind. Okay. Now it's important that you see that this is the test tube where we have dissolved. Sorry. This is the test tube where we have dissolved the solid product of from our evaporating dish, and it's now a clear, colorless solution.
This is a bunch of circles.
Really?
Sorry.
Can you help me with this next part? Now we have a solution of silver nitrate, and Lily's going to put 2 drops of silver nitrate into this solution.
Is it okay if I accidentally put like 3 or something?
Sure, it's okay if you put 3. Try not to put too many though.
2. I think that was 2, but I think
Perfect.
there might have been like half a drop.
What do you see, Lily?
It's turning like more cloudy.
Yeah. Just in case it's hard for you to see, there is a precipitate forming, and if I give it a good mix, then you can see that precipitate forms throughout the solution. So your lab manual will give you a clue for what that indicates. Okay, Lily. The next part is going to have to do with this flame. You want to play with the flame?
Yeah.
All right. So take this glass stir rod and dip it into the deionized water.
Okay. It's in.
Okay.
Now what?
And hold on a sec. Let me
Is this one the
let me get the camera pointed at the flame.
This one's the deionized water, right?
That's correct.
Okay, just making sure. How do you remember all the names to all this fancy stuff? School?
Yep.
You actually remember stuff from school?
Okay. So now we're pointed at the flame. Can you put the wet end of the stirring rod
Over the flame?
into the flame? Stick it right in there. Let it sit there. Do you see any colors or anything other than the blue that was already there?
It's turning kind of green in the middle. Right?
A little bit. Okay, now get the stir rod wet again, so stick it back in that
This
deionized water. Yep. Okay, and dip it into the
Powdery stuff?
powdery stuff. Okay, I'll show that to the camera. So there's lots of the solid on the end of the stir rod.
Is it going to turn...
Now stick it into the flame.
Is it going to... Hey, I knew it.
What do you see this time?
Orange.
Bright orange
Really
colors, huh?
bright orange, like orangey yellow.
Okay, and we're done
Actually, yellowy orange.
with the flame.
Hey, it wasn't done yet. There's still more solidy stuff.
Now, oops. Now for this next part, we're going to be taking a well plate and filling it up with a lot of different acids and bases, and running a number of different tests. So page 5 of your lab manual has a table that we're going to be sort of producing with these well plates. It'll take a while for us to fill all of them up, and so we'll see if Lily will help me with that. Do you want to come over here and do this next part?
Yeah.
All right, so we have here in the first row hydrochloric acid, in the next row sodium hydroxide, in the next row sulfuric acid, in the next row nitric acid, and then potassium hydroxide, in the first row of the next well plate, calcium hydroxide, acetic acid, and pure deionized water. We're going to be putting different reagents into each of the different acid and bases. Acids and bases. Yeah. And testing what happens. So the first is phenolphthalein. Phenolphthalein has the fantastic quality of combining 4 consonants in a row within its name of phenolphthalein, but it will also act as an acid-base color indicator. So under neutral and acidic conditions, phenolphthalein is colorless, as you see in the reagent bottle here. Under basic conditions, it is going to turn pink. Lily, would you like to put a couple of drops of phenolphthalein into the top cell of each column?
Okay. Why is acid always green in all the things?
In like TV shows?
Yeah.
Because they don't know what they're talking about.
So kids are smarter than them?
Yeah, probably.
Whoa.
Okay. And then the top of this other set. Hold up. Saturated
That's
calcium
pretty.
hydroxide.
That's pretty bright pink. Very vivid. I don't know where I learned the word vivid.
Our calcium hydroxide doesn't seem to be working. It's possible I grabbed, I don't know, a low concentration from the stockroom. So I'm going to go ahead and cheat for all of you and make sure that the calcium hydroxide responds in the way that it's supposed to. Excuse me, Lily. Okay, I don't know what the problem was, but I just fixed it.
Now there are 3 pinks.
Can you put the phenolphthalein back there?
That's cool how it's a cap and a squeezer.
Yeah. Okay, the next is a color indicator called bromothymol blue. Oops, there we are.
Wait, bromothymol?
Bromothymol blue. And there are lots of different color indicators
Green
out
to
there.
me.
Well, Lily, why don't you put a drop in each of the second row, and let's see what happens with the bromothymol blue. Just one drop will be
I
fine.
know, but it's a big drop and it won't go. That's not blue. Go. Go. Go drop. Oh, that one's blue.
Why don't you put a couple drops?
Oh, okay.
Sorry, it's not quite as dark as I was hoping it would be. Okay. can grab some more for the next set.
Knew it. I'm like, there has to be sun green in this, right? Because it's green.
Okay, so you see bromothymol blue has a bit of a wider range of colors.
It's got orange and yellow and green and blue.
I'm actually gonna see if we can't get even a little bit closer.
There.
Is that even better? Let's do this.
Some of the pink is fading away.
That's okay. All right. Next we have what's called a universal indicator. Universal indicator is just a mixture of several different color indicators.
Wait.
And I'll be sure to provide a picture reference for you about what the colors mean.
Daddy,
Yes, hon?
can I make an observation?
Yes, please do.
So when it was clear, this was clear, and when it was green, this was green. So is this one going to be red
I don't know.
on that line?
That's a good question. Let's find out. Will the color of the water in the universal indicator solution match the... Nope.
Huh?
The third row.
Oh, oops. So far, just red and purple.
Okay. That is the universal indicator.
Ooh, that smells sweet.
Now we have
Really, it smells like cinnamon.
two more tests. One of them is to put little flakes of magnesium.
What's magnesium?
It's just a metal.
It sounds like a super fancy name for like the kings.
So
Way back.
that's what magnesium looks like. We'll just put a few flakes in here. What do you
Whoa.
see, Lily?
It's bubbling
Bubbling.
and fizzing a little.
Cool, huh? A few flakes in there.
It's not doing much in that one.
Okay. Some flakes in there. What's it doing?
That one's bubbling, but not quite as much. And it's not really fizzing. It's just bubbling.
Okay. This one?
Whoa, that one is bubbling like a lot. A lot.
This one?
It's not really doing anything.
This one? Ooh, way too much magnesium that time.
Also not doing much.
Two more. This one?
This one's fizzing a little, but not very much. And it's not bubbling, just fizzing.
And the water.
And it's doing nothing.
Okay, and then we've got one last test. And that is calcium nitrate.
Is this
So-
calcium nitrate?
Yep, that is calcium nitrate. So the last row here, Lily, can you put a few drops of calcium nitrate into each of the last row?
Okay.
So calcium hydroxide is actually only a sparingly soluble salt. And in basic conditions, the calcium hydroxide is going to form a precipitate.
It's getting a little cloudy in that one, but that's all.
Yeah, this may actually be useful.
I can't remember if it.
Hold on, can you back up a bit? I'm going to put a piece of black paper under there. And
Oh, it's cloudy too. That magnesium almost fooled me, because in the one when you put a lot, I thought it went over another row. So when I did that, I'm like, oh shoot! I just did the magnesium one now.
so this one here, the calcium hydroxide, looks like I didn't tweak it quite well enough, so I'm going to cheat for you once again. That's what the calcium hydroxide is supposed to look like. Okay, and that is the lab. So we've got some questions for you to answer.
Questions I was asking, or like more complicated?
In your lab manual. And I hope you enjoyed this video presentation of the lab. And Lily, do you want to wave goodbye to them?
Bye bye. Oh, wait. Sorry. Monkey and koala also.
Monkey and koala also want to wave bye.
Hey, that camera's back.